Assalamualaikum and hi. Today our group 4 will presenting about the factor affecting the efficiency of the absorption process. Right, so this is our team members. This is our overview. We will discuss about the introduction, properties of absorbent, properties of absorbate, operating parameters, supplemental example, absorption kinetics and thermodynamics, conclusion and recommendation. So we move on to the introduction. So, the definition of absorption. Absorption is a surface phenomenon where molecules from a liquid, either gas or liquid, accumulate on the surface of a solid or liquid, forming a thin film. For the importance, we have a three application, which is in environmental application, medical application, and catalysis. For environmental application, it is widely used in the water and air purification to remove contaminant and pollutants. For medical application, absorption is employed in a drug delivery system and in the development of biosensor. Catalysis, many catalytic processes rely on absorption where reactant absorb onto the surface of a catalyst to facilitate the chemical reaction. We have two types of absorption, which is physical absorption and chemical absorption. For the physical absorption, it involves the weak van der Waals forces between adsorbate and the adsorbent, while chemical absorption it is involved the formation of strong chemical bonds between the adsorbate and adsorbent. For the characteristic of physical absorption occur at low temperature, no significant changes in chemical properties of the adsorbent and multi-layer absorption is possible. For the characteristic chemical absorption typically occur at higher temperature, irreversible due to the formation of chemical bonds, usually result in monolayer absorption. So we go to the properties of adsorbent. So we focus on the surface area. Surface area refer to the total area available on the surface of an adsorbent for absorption, typically measured in square meters per gram. The importance is a surface area provide more active site for absorption, which increase the adsorbent capacity to absorb more molecules. For the material like activated carbon and zeolites are designed to have extremely high surface area to enhance the absorption performance. The measurement used is a Brenner-Emmett-Taylor BET method. Next, we go to the pore distribution. Pore size distribution describe the range and proportion of different pore size within adsorbent material. So we have a three typical categorized pores, which is microspore, mesopores, and macrospores. For microspore, contribute significantly to the overall surface area and are crucial for absorbing small molecules, while mesopore facilitate the diffusion of molecules into macrospore and important for absorbing larger molecules. Macrospore serve as a transport channel which allow the molecules to reach mesopores and microspore. Optimal pore size distribution depends on the specific application and the size of the molecule to be absorbed. The measurement techniques used are such as the nitrogen absorption, desorption isotherms, and mercury intrusion porosimetry. Thank you. That's all for me.
So I'm going to talk about the adsorbate. Adsorbate is any substance that has been absorbed onto the surface of a solid or liquid. This process, known as absorption, involving the adhesion of atom, ion, or molecule from the gases, liquid, and dissolved solid to a surface, creating a film of absorbate on the absorbent surface. Next, I'm going to talk about the properties of the absorbate, which is surface area. Definition of the surface area is a specific surface area is defined as a total surface area of a material per unit mass. It indicates on how much surface is available for absorption relative to the mass of the absorbent. Next, the second properties of the absorbent is molecular weight. The molecular size of the absorbent refer to the physical dimension, which is such as diameter or volume. It is important to define on how effectively and how much of the absorbent can be absorbed onto the surface. Next is the properties of adsorbate, which is concentration. Concentration of adsorbate refer to how much of the substance is present in the surrounding medium that can be observed onto the surface of an absorbent. It can determine based on how much absorbate can be captured by the absorbent. Next is I'm going to talk about the operating parameters. The firstly is mass contact. It's refer to the amount of the time absorbate remain in the contact with the absorbent. Next is mass of the absorbent. It's refer to how much the absorbent material is used in a process, and it's play a major role in determining absorbent can occur. The third one is concentration of the adsorbent. The amount of adsorbent present in the medium that available for absorption onto the surface of the absorbent.
Starting with pH, it significantly affects the absorbent surface touch. At low pH, surface are photonate, making them effective for absorbing anionic species. At high pH, surface are diphotonate, favoring cationic species. Graphs show that chromate species such chromate dominate above pH 8, while acidic pH favor hydrogen chromate ions. We can look the graph percent removal vs pH values. Next, temperature impact absorption efficiency. For exothermic processes, lower temperature enhance absorbance, while higher temperature reduce both capacity and removal efficiency. A study with Kalenite showed decreasing absorption of CO2 plus and nickel 2 plus as temperature increases under consistent conditions. Next, agitation rate is another important factor. Faster stirring improves adsorbent-adsorbate interactions, increasing efficiency until the equilibrium reach. For example, dye adsorption on the montmorillonite initially increases with stirring speed before stabilizing. In the case of study, we examine the absorption of dye on activated carbon. In this batch experiment, we vary the contact time to observe the efficiency of dye removal. The results indicate that dye absorption occurs most rapidly at the beginning and after about 55 minutes, the removal efficiency stabilizes. As seen, as seen in the graph, there is significant increase in the dye removal at the initial stage, with the process stabilizing after approximately 55 minutes.
Next, I will explain about adsorption, kinetics, and thermodynamics. Let's start with the adsorption models. The Langmuir isotherm model. The Langmuir isotherm model assumes monolayer adsorption on a uniform surface with no interaction between adsorbed molecules. The equation for Langmuir isotherm is delta equals to Kp over 1 plus Kp. The delta is the fraction of filled surface size. P is the pressure and the K is the Langmuir adsorption constant. Next is Freundlich isotherm model. It describes adsorption on heterogeneous surfaces, which adsorption capacity varies with concentration. Freundlich adsorption gives the variation in the quantity of gas absorbed by a unit mass of solid adsorbent with the change in pressure of the system for a given temperature. The expression for the Freundlich isotherm can be represented by the following equation, which is X over M equals to Kp to the power of 1 over N. X is the mass of the gas absorbs. M is the mass of the absorbent, N is the constant, and the P is pressure. Now let's move to the thermodynamic parameters. First, Gibbs free energy, represented as delta G, indicates whether the adsorption process is spontaneous or not. The equation is delta G equals to delta H minus T delta S. Delta H is enthalpy, T is temperature, and S is entropy. So, if delta G is less than 0, the process is spontaneous, which occurs naturally without needing external energy input. But if the delta G is greater than 0, it is non-spontaneous, which does not occur naturally, and it requires external energy or intervention. Next, enthalpy, delta H, measures the heat exchange during adsorption. A positive delta H indicates an endothermic process, while a negative delta H shows exothermic behavior. Finally, entropy S reflects changes in randomness at the interface. Positive delta S suggests increased randomness, and negative delta S indicates decreased randomness. These parameters provide a deeper understanding of the energy and molecular changes involved in adsorption. Next, I will pass to my partner.
All right, thank you, Hafiz. So I will continue with my part. Is conclusion and the recommendation. So what we can conclude from our assignment is the first one. We will know the definition for adsorption is a surface accumulation of molecules from a fluid into the solid or liquid. The next one is operating parameters for adsorption. We know the contact time, mass of absorption, solution pH, temperature, and agitation rate. For the next one, we also can differentiate the what is the mean by adsorbent and adsorbate. So the next one is recommendation to get the better result is the first one is the high performance adsorbent. We use the materials that have a high surface area like activated carbon, zeolites, or metallic organic framework (MOF). So the next one is we must to optimize operating condition like we adjust the pH or the temperature. For implement regeneration technique, we maybe can incorporate cost-effective regeneration method like the thermal exhaustion or pressure swing absorption to extend the adsorbent lifespan and reduce the waste. So for the last one is leverage and advanced technologies. We use the nano engineer absorbent or hybrid system. So that's all from us. This is our reference. So thank you.